All right, what is up, everybody? Welcome. So today I'm just gonna be learning about like polar coordinates in Calc 3, and then double integrating with, in polar coordinates. Bro, which one is it? Oh, it's this. Okay. So, first we have area. Now, this one, I was actually at the doctor's office yesterday, and I asked the lady for a piece of paper, and I kind of figured this one out. So, if we have x and y, xy equals area, right? Now, let's say we had a parametric equation that gives us x, and then a parametric equation that gives us y, right? So that gives us area, and essentially like how quickly we were moving through that area, or like how quickly we're moving through a certain space's density, right? Like, I don't know. I don't really know how to put this. So let's just make a coordinate plane. So if we had this is x and this is y, and then a function of x and y gave us like every point. Let's say we got like this circle here. If it took from like t equals, I don't know, this is from like t equals 1 to I don't know, like t equals 5. Like that's 4 right there. Like that's a lot in that tiny little area. But this circle right here, let's say it was traveling really, really fast, and this is from t equals 0.5, 1 to 5, and then let's say this is t equals 0.5, and then this to t equals 1. This whole thing would just be 0.5. So I'm saying like the more t that's in that area gives us like how dense it is. Like the more, literally like the more matter in an area. So if we had like in a function f of x, y, or like a vector f x t y t, then we could figure that out by this is just a guess, by the way. Integral, double integral dx dy. Because we're just saying that's density. It's kind of like a complex function, or even kind of like a 3D function where you have density, and you can find that. I don't even really know what the fuck I'm just talking about here, but this gives us area. And then if we integrate, if we have like f equals, z or something, we're doing this in 3 coordinates, then we're essentially figuring out how much z there is in that span. Dude, I feel like I'm just like rediscovering like basic shit. But I mean, that's good though, because like that means I'm able to kind of understand it on a fundamental level. So if xy equals area and x equals dx, y equals dy, then that's how we figured that out. But area in polar coords is given by pi r squared, but we don't want pi. You know what I mean? So what we're actually going to do is we're going to do this for the angle over 2 pi, which gives us 1/2 theta r squared equals area. And so that gives us area. We can describe this using integration by breaking into pieces. So r would be the integral of, I mean, I guess that's technically just r times r. I mean, we could go with that. We could just go with that as well. So RDR, and then theta is obviously just d theta. So we have 1/2 integral second integral, and then we have r dr d theta, which technically equals a triple integral if for some reason you want to integrate radius twice, but that's kind of retarded. So like that was like a very retarded idea. I genuinely should not have even like written this. So I mean, this can also be derived with Jacobian matrices. Keep that in mind. Not even derived like that. Like Jacobian matrices is actually like the way you figure it out, and this is the back road pretty much. Jacobian matrices is the freeway, gets you everywhere. This is like the back road that gets you to the McDonald's that's really fucking close to your house. You know what I mean? So this is this is equal to area. Such that if this is area and then we multiply it by some z amount, we get volume. Same thing with this. If we double integrate here, z dy dx. Yeah, that gives us volume, assuming z is like a function of x and y. We'd actually need to integrate. If it for some reason was a constant, we could just move that bitch out of there and then just have x, y, z equals volume. I think towards the end I was trying to figure out how this shit worked in spherical coordinates. So we have that equals area. Same story, assuming z was a function of one or a function of the other, we just do that shit. Spherical coordinates. Yeah, dude. I don't really know, dude. Shit is retarded. Spherical coordinates. Damn. How do you... Ooh, what the fuck? So we have this shit. This times z would give us volume. Now with spherical coordinates, I'm pretty sure. So, I know what the fuck they are. No, I don't want to draw a fucking arrow. I just want a line, dickhead. Here. Oh my god. Here. Here. X, Y, Z. I don't fucking like Z. Who is Z? And then here we have theta, R, and then I've seen this denoted as rho most of the time, and then this shit is phi, which it's phi. So rho equals, I mean, I guess that's just the relationship between X and Y. It's just between R and Z. So, one half phi. Z squared plus R squared equals. The fuck does that equal, dude? What the hell? Oh my god, this is so annoying. So this times Z. I don't know. I'm pretty sure it's just arc length times 1/2 of the radius, like. Right? Okay, so area is pi r squared. So arc length S, I'm pretty sure is just. Okay, so the circumference of a circle is 2 pi r. So that's for the entirety of the circle, so I just need to multiply this by theta over 2 pi to get arc length equals r theta. Arc length equals r theta. So walking into this knowing that area must be, that's 1/2 theta r times r. It's just r over 2 times that. So that gives us our area. Now to expand that to volume, we need to get not our arc length, but I'm pretty sure it's surface area. What the fuck gives you surface area, bro? What gives you that? Like, actually, like, what the hell? What the fuck gives you surface area? I mean, like, there's an integral for it, and I could just, like, revolve it around, but fuck. Okay, let's think about this critically. Nothing's coming to mind. Bro, trying to derive where spherical coordinates come from is fucking crazy. So it's this times z. But what the fuck does z equal? Z equals rho times the sine of phi. X equals r cosine theta, y equals r sine theta, so z r squared sine theta cosine theta, and then rho equals r squared plus z squared square root of that. Equals sine, nope, not, and then what was it, r squared plus z squared equals x squared plus y squared plus z squared sine this, right? Yeah, it is right. Yeah, what the hell? So if we square it, we have z squared equals x squared plus y squared plus z squared sine squared. God damn it, bro. I keep putting a theta on accident. There's got to be a better way to describe this. Oh, x equals r squared cosine of theta squared equals r squared cosine of theta squared plus, oh no, this is just gonna collapse it to fucking r again. Damn it. Z squared minus z squared times the sine of theta. Not theta, phi. It's the square of the sine of phi, and then that's, I'm just gonna call that r squared sine squared phi, and then we have, let's take the square root of them shits. We have z square root 1 minus sine squared that equals r sine squared phi. Nope, sine phi. Z cosine. God. Doing homework. Okay, so we essentially have the tangent of r equals z. Tangent of phi times r equals z. Yeah, dude. So I mean, technically we could go x over y. Or no, y over x. Because that's r over r and then sine. Oh wait, no, that doesn't even work because those are for theta. Well, fuck, bro. I don't really know what to do here. Cause sine squared plus cosine squared equals 1. I don't really know of a way to collapse this equation, if I'm gonna be fully honest. So yeah, let me see something. If we damn, no. Oh, shit. Bro, this shit is actually annoying. Like, genuinely annoying. Is it just, do I just multiply the area by 1/2? No, I can't, because it's all gonna converge to 1 point. Damn it. Fuck. I'm just gonna bring that down a little. Yeah, bro. I don't know. I don't know. Let's bring that in there, I guess. Equals 1 over x squared. That's y times 1 plus y squared over x squared. I feel like I'm actually finally like getting somewhere. And And then if we do this, that equals 1 plus y squared over x. No, it gives us y squared plus y to the 4th over x squared. I don't even know if that's correct either. You know what I mean? Like, I don't. Fuck. How do you get. Whatever. I'll probably learn that shit later. Anyway, let's check the Discord, and yeah, we were given some practice tests.
All right, you guys. So
What the hell? Okay, so if I remember my hyperbolics correctly, that's e to the x minus e to the negative x all over 2 equals sine hx. Fairly sure. So if we integrate that, x cubed. Pretty sure that's non-elementary, but that's okay, because we know that e to the x equals the sum from n equals 1 to infinity of x to the n over n factorial. So e to the x cubed is just to the 3n. X cubed, and then to the n power, yeah, equals sum 1 infinity x to the 3 n over n factorial. And then if we integrate that, fuck? I don't know. Yeah, if we go like term by term, that's x to the 4. And then if we integrate that, that's I'm pretty sure. Because the thing about n is like for every single term, it's a constant. Like x is the only really thing that's really changing, and we're integrating with respect to x, and then we're also integrating with respect to y. Am I doing this right? Because this seems like really easy. Integrate, evaluate, int e to the x to the third power dx using the infinite sum and show steps. Let's see it. Oh, that was stupid. That was actually really stupid of me. I did not do that right. What the hell? Oh my god, that's bad. That's really bad. Oh my god. Youch. Yowzers. Oh. Okay. Well, that's fucking horrendous. I mean, I was glad I saw that and thought, nah, this is way too easy. So yeah, this is a constant. So if we integrate that, I forgot what it was doing. So I don't know. Let's try to retrace the steps. So that's in the numerator. We add 1. Oh my god. Yeah. And then we add 1 in the denominator. So we have 1 to infinity. Right, because that's just a scale factor, technically. And then we integrate 3 times whatever n is dx yeah, that's just 3n plus 1. I'm not sure how I got a 5 on Calc BC. Like, actually, like, I'm just losing my shit. I didn't practice my fundamentals enough, so I was able to perform well for the test. So we did 1. Now I need to do e to the negative. So e equals x to the n. So if instead of x we had... Okay, well first let's plug in x cubed. So we have negative x cubed. And then we plug that in. So we have negative x cubed n. Cubed to the n power. E to the negative x cubed equals 1 infinity negative 3 or negative x to the third to the n and factorial. Not too shabby, not too shabby. Not too... I'm sorry. Yeah. Ooh. So technically this is negative 1 times x cubed to the n. So we have 1 infinity. And then we have negative 1. So it's alternating. And then we have x to the 3n. And then we're going to put this one over n factorial. So we just have sum 1 infinity and then, yeah, that's also 3n, so we can just say it's that. Negative 1 n factorial 3n plus 1, 3n plus 1. I need to start adding the little header things on there. Okay. So if we're adding those, or if we're subtracting one from the other, technically we're subtracting this one here. We're subtracting this one minus that. So what I say we do is we just put n plus 1 up here. So boom, we have, because that's technically going to give us a negative 1 times whatever's on the inside of this, right? So that's just technically negative 1 times negative 1 to the nth power, which is just negative 1 to the n plus 1. 1 infinity negative 1 n plus 1 over n factorial x 3n plus, what the fuck am I doing? 3n plus 1 3n plus 1. So that's when we integrate with respect to x. So that's 1, and then we're adding this sum here, 1 infinity, and then we just have 1 over n factorial x 3n plus 1 over 3n plus 1. Now if we're adding those together, we can essentially just say like sum from 1 to infinity of this plus this, like those two, like added together in parentheses, times the rest of this. So yeah, let's write that down here. 1 infinity -1 and +1, and then we have essentially just +1 times in the very bottom we have n factorial 3n + 1, and then we have x to the 3n + 1. So that's when we integrate that straight just with respect to dx. I'm not really sure why I did that, because that wasn't a part of the problem. So what I'm fairly sure we need to do here is we need, oh, it was that whole thing, but in half, because it was over 2, because it was the hyperbolic sign. So, I don't know, chain rule? No. Okay, so x has to be in between the square root of y and 2. X, those are x's bounds, and then y itself has to be in between 0 and 4. So if we square all of these, y x squared 4, and then 0. So if we want to switch these, like these limits, we want to switch the order. dy needs to come first, such that we can use the chain rule. Maybe, I don't know, that's an x cubed. Ugh. You know, I don't know, dude. I genuinely am unsure. I forgot how to switch limits. I don't want to draw a fucking arrow. Let's just draw like a graph. This is x, this is y. Looks kind of like a special needs x. And then y has to be between 0 and the square root of 4, which, I mean, if we're only taking the positive 1 into account, because it has to be greater than 0. So it has to be between or equal to 0 and 2. So we're going to cut that bitch at 2. And y equals, or y, I don't know, what the hell, x? I'm pretty sure x, it's also 2 as well. Let me check. Dx 2 and the square root of y. Yeah, exactly. So if we draw out the square root of y, let's have 1 here, 1 here. Goes up a little. Pretend that those hit like right there. And then we have that bitch like right there. So this is what we got. how do I get this? Okay, so we can just make that a dx by... So this is 2. That's the biggest x can get. What is this from? 0 to 4? How do you switch limits? So let's just rewrite this with dy dx instead. So y's got to be between 0 and x squared. There's 1. So sine, hyperbolic sine x cubed dy. Y's got to be between 0 and x squared. Oh, so after that we can use sub because it's cubed, so then it'd be a half or a third. Fucking hell, dude. Dx, and then x has to be between 0 and 2. Right? Yeah. I'm fairly sure I did that right. Oh, wow. I was wrong. What the hell? Y is in between 0 and 4. X squared 0, x equals 2. Oh, I did it right. Because y equals 4 and y squared. Okay, so I did it completely right. I don't really get why we're writing the 4 on there. Like, I don't understand that. Am I dumb? Y equals x squared. I could have got that one really wrong. Okay, so yeah, we switched the limits. By the way, the switching the limits quiz was the first quiz. This is quiz number 12, by the way. It's the first quiz that I've had that I actually just like knew my shit to a T. So that was a really good feeling. So if we integrate that with respect to dy, the hyperbolic sine of 0 is 0, and then it's just y times that thing. So we essentially have 0 to 2 of x squared sine hx cubed dx. Now if we have u equals x cubed, we have du equals 3x squared dx, such that yeah, it is a third. So we have And then 2x cubed, that's 0 to 8. So we have 1/3, 0 to 8. Sine h u du. Now, I don't know what the hyperbolic sine of 8 is. I don't feel like computing that. But we have... Actually, I might have to compute it. So we have 1/3. And then we have e to the 8 minus e to the negative 8 over 2 minus e to the 0 minus e to the 0. So 1 minus 1 equals 0 over 2. I don't really know or care what e to the negative 8 is. I don't know. There's probably some algebra I could do. Let's think about that for a sec. So e to the 8 over 2 minus e negative 8 over 2. E over 2 minus 1 over 2e to the 8. So e to the 16th over 2e to the 8th minus 1. Technically it's over 6 because it's a third. Fairly sure that's correct. What? Yo, what the hell? It's plus? Since when is the hyperbolic sign plus, bro? What? That's so dumb. That's so dumb. What the